Sorry about all the writing. I just had to make sure that the camera wasn't shaking as much when I was doing the questions. So this should be better. Okay. So this is question 8 of 2008. A locomotive of mass 20 times 10 to the 3, moving at 8 meters east. Okay, 20 times, yeah, I already wrote that in. Moving at 8 meters east, collides and couples to 3 trucks, each of mass 20 times 10 to the 3. So that's all here. Initially stationary. These aren't moving. Okay. So you look at this. It's a collision. It's going to be energy or momentum, most likely. Yeah, it's going to be one of those two. So this one looks like a momentum question. What does it ask? What is the speed of the coupled locomotive and trucks after the collision? You must show you're working. Momentum question. So this is before, and this will be after. All we need to do is figure out the momentum before and make it equal to the momentum after. Momentum before is the mass, 20 times 10 to the 3, times velocity, 8. That's the only thing moving, equals 160 times 10 to the 3. 8 times 20, 160 times 10 to the 3. Afterwards, we know everything's coupled, so now their mass is the sum of all of these. 80 times 10 to the 3. Momentum's the same. And now it's moving at some velocity v. So this is like m, and that's v. So we know it's equal, so that equals that. Therefore, times v, or v equals 160 times 10 to the 3 over 80 times 10 to the 3 equals 2. Velocity equals 2. I still haven't solved this moving camera thing. Give me some time. Just bear with me for now. What is the impulse given to the locomotive by the trucks in the collision? You must show you're working. So impulse is change in momentum. So I want to figure out the change in momentum of the locomotive. Given to the locomotive, yeah. So if we figure out the change in momentum of the locomotive, that must have been what the trucks did. So initial momentum was 8 times, so it was mv equals 20 times 10 to the 3 times 8. Subtract, it was moving at 2 meters per second again, that's mv. It's mv, m 20 times 10 to the 3 times 2. So the answer is, that becomes 160 times 10 to the 3 minus 40 times 10 to the 3. 120 times 10 to the 3. I feel like it was 10 to the 4. No, 10 to the 3, lucky. Now which direction? So initially it was moving this much in that direction, and then at the end it was moving this much in this direction initially, and then it was moving this at the end. So therefore must have lost 120 going in this direction. That's what the trucks did. And it's kind of obvious that the trucks would have stopped his momentum by going that way. Was the collision elastic or inelastic? So elastic means, well, inelastic collisions mean loss of kinetic energy. Elastic collision means we have full kinetic energy. So we just need to figure out how much kinetic energy we had over here. So initially we had only the truck moving, locomotive. Loco equals half mv squared. So initial energy equals half times 20 times 10 to the 3. Oh, you can't see that. So when it's the mass times the v squared, which was 8 squared, equals 640 times 10 to the 3 joules. Okay. So final energy equals, so then we know 4 of them, the mass of 80 times 10 to the 3 were moving at 2 meters per second. Half 80 times 10 to the 3 times 2 squared that's the mass using this formula. And that's the velocity squared. It's 40 times 10 to the 3 times 4 equals 160 times 10 to the 3. So we lost a fair bit of energy. Therefore, inelastic loss of energy. During the collision, the magnitude of the average force exerted by locomotive on truck is FL. The magnitude of the average force exerted by the trucks on locomotives is FT. And locomotives by the trucks. So on the locomotives by the trucks is FL. So this is how much these things are affecting. Sorry. No, wrong way. By the locomotive on the trucks. So the locomotive is affecting the trucks by FL, that's the average force, and the trucks are affecting the locomotive by FT. Now, this question is asking, is FL greater to or less than FT? So which one's bigger? So first of all, there's a few laws we can use. If this is exerting this much momentum on that, it must be exerting the same amount of momentum back. Therefore, forces must be equal. Or we could use Newton's third law. Newton's third law. And say forces are equal in opposite directions. If they exert a force on you, you can explain the rest of it, but these are the key points. Forces are equal in operation. Therefore, FL equals FT. Easy. I think that's done.